Good morning and happy Wednesday. We've got some new notes today, but still we're working on the same thing. So I'm going to quickly explain what these notes are talking about so that you can refer back to them for today's work. So we have been talking about linear functions, and I'm going to go back real quick to slope-intercept form. This was our first look at linear functions. And I told you guys this is slope-intercept form. The reason it's called slope-intercept form is because in this form you can see the slope and you can see the intercept, the y-intercept. So this is called slope-intercept form, and it's the standard form that you want to get your linear equations in because you can see everything that you need to see to graph your equation. You can see where you need to start on the graph, and you can see where you need to move. So this form, you're going to see it a lot. Your goal is to always get it to this form. This is a form that we really like. And so I showed you some examples of how you can look at an equation, see where to start and how to move, and that tells you how to graph. Now, I have not asked you guys to graph yet. This is just a visual for you to see what this represents. So you can see where you need to start and how you need to move. So that's slope-intercept form or standard form. Now, if you only see x equals a number or y equals a number, you know that that is going to be a straight line, either up and down or side to side. It doesn't have all those other variables in it. It just has x equals a number or y equals a number. And then yesterday I showed you how if someone gives you one single point and the slope, you can use your standard form, plug it in, and figure out what's missing. So if they give you a point that you plug into the x and the y and the slope, you can solve for this missing variable. We know how to solve for a missing variable. We've been doing it in all of our multi-step equations. We've been solving for x, but here we can just solve for b. So I showed you how if they give you everything meaning b and m, then you're good to go. So I don't want you to look at this function and say, well, it looks like I'm missing an x and a y. You're not. Those are characteristics that tell you something. When you have y set by itself equal to all of these things, it's going to tell you which way the graph is going to look. If you see the x with no exponent, no squared, the x isn't risen up as an exponent, it's just sitting right here right beside a number, that shows you that this is a linear function. This is the slope and this is where you start. And so you can look at that and see, oh, this is linear. I can tell by the characteristics. But if they haven't given you the equation and you need to know the equation, you can get it from a very small amount of information that's given to you. So if they give you a single point and a single slope, we write down all the variables that we have. We just don't have b. Plug it in. So instead of using the letters, we plugged in the numbers we had, simplified, moved it so where our letter was by itself, and now we can write our equation. But there's another way to do this. So if this way works for you from yesterday, where you plug in the x and the y and the m and you solve for b, then that's perfectly fine. But I want to show you something else in case you do see it this way. It's called point-slope form. And so it's y minus y1 equals m parentheses x minus x1. And when we do this, we're going to end up getting it into standard form. So right here, you'll see I wrote, and again, these are new notes for today. So if at any point you need to pause this video, write this down, and then unpause the video, please do so at your own pace whenever you need to. If a single point and the slope are given, so just like I gave you yesterday, you can use the point and the slope, you can use point-slope form to plug in the values to get the answer into standard form. So we can go from point-slope form to slope-intercept form by just moving things around. So I noted down here, you can also plug point and slope into standard, solve for b, and rewrite. This is just another method. So they both work. And if one works better for you, then go for it. So in this first example, again, I only drew the graph so you can visually see it. Don't worry about graphing it just yet. If I give you a point, -6, 8, and I give you the slope, for today, we're going to use point-slope form to get our standard equation here. So I labeled that this is my x in the first coordinate and my y in the first coordinate. Okay. And then they already gave me my slope, and I know m stands for slope. So if the formula is y minus y1 equals m parentheses x minus x1, then I'm just going to plug in what I have. I have the y1 right there. I have the x1. So it's x minus, and my x1 is -6. So I had to put the -6 in there. The minus did not mean that the negative was already there. The formula has negatives. If the number has a negative, that doesn't mean that's not the same thing. This goes there. A negative number still has to have its own negative symbol in there as well. And that's how you know two negatives will end up making a positive right here. So minus -6 became plus a positive. And then I know the slope is 1/2 because they told me. So I literally just plugged everything in that I could into the point slope form. Now we just simplify it, right? So I distributed this 1/2 to both of those and got 1/2 x plus 3, right? Half of 6 is 3. Now I want to get y completely by itself because I know a lot of times you're always solving for x. And so I'm like, all right, you need to get x by itself. Or in yesterday's example, we were solving for b down here. We were solving for b. That was the variable that was missing. So we got b by itself. But in this equation, we're trying to get y by itself because we want to get it in standard form, which is right here. So we want the y to be completely by itself, set equal to a number, or the slope, attached to the x, and we have the number attached to the x, plus b, plus b. So we have what we need on this side. What's wrong is that we have too much on this side with the y. So in point slope form, you're going to distribute and move things away from the y. And so again, all of these forms are a little different. The operations that we're doing are all the same. It's just that we're getting a different variable completely by itself. In multi-step equations that say solve for x, you would get x by itself. If you've been given the slope and a point and you plugged it into standard form, the only thing you don't have is b, which means you're solving for b, which means you'll get b by itself. And in this equation, as you can see from this standard, or from the point slope form that we have here, once we distribute, I can see that I have a slope. I can see that I have a variable back here for b, but what's wrong is I have too much over here for y. So if I'm trying to get it in this form, I can see that there's too much over here. So I've got to move this over. So you just have to be intuitive of what you have and how you're working. Which form are you using? And how are you going about that? So if you're using point slope form, you need to get y by itself. If you're using standard form and plugging it in, you need to get b by itself. So I moved this 8 over and got y equals 1/2 x plus 11. So this final answer here tells me that I'm going to cross my y-axis at 11. That's that b value in the back, which is my y-intercept. Think of like in football when someone intercepts the ball, like an interception. They are touching it, they took it, they grabbed it, and so that's where it touches the y-axis. And then the 1/2 is my slope, right? Up 1 over 2. So from 11, I just went up 1 over 2. So I went positive, positive. You can also go negative, negative, and you'll still land on the same line. Either or. Again, this is your visual of what this equation tells me. So we're going to do one more together on your notes page, and then I'll give you some practice for today. So I've given you the point 3, -2, and the slope -1. So I'm going to label. Always, always, always label your x and your y's because everybody gets them mixed up, and you can never, it's never a bad thing to label them. You're never going to hate yourself for labeling them. It's going to help you in the long run. So if the form is y minus y1, then I'm going to do y minus, and there's my y1, -2 equals m parentheses x minus x1, which is 3. And if you're wondering, how did she know what that formula was, the y minus y1, m, and all that? I'm looking right here at the top of my page. And I'm like, okay, I've got my x and my y for my coordinate to fill in right here, not these two. These two. That's why we label them x1, y1. And I know that m is slope. So I'm just looking at this and filling in all the things that I can. We know in standard form, once we get it there, in slope-intercept form, once we get it there, I want the y and the x. I want those letters to still be there. The numbers that I'm looking for are my m and my b. So when I come down here and I look, it's okay to have this y and this x. I know in my final answer, I'm going to need those. What I'm trying to do is figure out what the m is and what the b is by rearranging all of this. So over here, I know that two negatives make a positive. And over here, I know that I need to distribute. So I have y plus 2 equals negative x plus 3. The reason I got that is because negative 1 times x is just negative 1x. We don't ever really write the 1. And negative 1 times negative 3, two negatives make a positive. It's positive 3. So now I need to do one more thing, which is get y completely by itself. So I'm going to move this 2 over here and write y equals negative x plus 1. Now, when you look at this, some of you are going to say, I don't see the slope. And I will tell you what I always tell you. What number is in front of that x that goes with that negative symbol? An invisible 1 that we can't see. And then, how do you make any whole number a fraction? We put it over a 1. So really, this tells me it crosses the y-axis at 1, and it has a slope of 1 over 1. That's it. I'm sorry, negative 1 over 1. Let's not forget our negative sign. And so I can see all the important information from this final slope-intercept form that we got down here below. I'll graph it for you just so you can visually see what this equation means and just kind of show you that. So over here, so it crosses at 1. So I'm going to go up on the y-axis to 1 and put a point. Okay? And then my slope is down 1 over 1. So I'm going to go down 1, which is negative, then to the right 1, which is positive. Down 1 to the right 1. Down 1 and to the right 1. So on and so forth. Now my lines don't really line up very well. And I'm horrible at making straight lines, so I try my best. There we go. That's a terrible line, but you understand. So from this equation, I'm able to do this, and we're going to get to this at some point where you guys are able to graph from the information you've gotten from your equation. So again, today's notes, point slope form, you can get it into, I shouldn't say standard right there. I do apologize. Let's change that to slope intercept. There we go. Sorry about that. So from point slope form, you were able to get it into slope intercept form by getting y by itself. Okay, because you know that it's going to have a y and an x in the answer, and you already have the m and the b part of the b. You got to move this over here to get the final actual answer of what b is. So you can go from point slope form to slope intercept form using 2 points in a slope, or you can actually use slope intercept form with your point and your slope. So there's 2 ways you can do it. You can use these notes from yesterday if it works for you, plugging in your x and your y and your slope and solving for b. Or you can use today's notes, using point slope form, plug in your x and your y and your slope, and simplify and move everything away from the y. Neither one is wrong. Both are right. Both work, as you see, but some people do have a preference, and that's totally fine. But I wanted you to be familiar with this, and I want you to try this method for today. And so, as you can see, like for this example down here, once I plugged everything in, I can see that my slope is here, but this does not mean that that's what my b or my y-intercept is, because we're not done yet. We haven't simplified. Once I move this 8 over, well, first, once I distribute that 1/2, it's still, 3 is still not my y-intercept. Once I move this 8 over, now I finally have the true y-intercept of 11. So don't plug everything in and just say, oh, this is my slope, this is my y-intercept. No, you have to simplify your equation and get everything away from y. So thank you for taking these notes for today. I'm going to give you some practice to work on this using one point and one single slope. Plug it in and get it into slope-intercept form for me. You'll have some problems for that. And then, let's see, tomorrow you're going to practice doing more of this, and you can use both methods. You can use slope-intercept form to solve for b, or you can use point-slope form and get it into slope-intercept form. Either one works. So go ahead and get your notes copied down if you haven't copied them down in this video with me, and work on your practice for today.